Have you ever felt a sense of déjà vu so strong, so real, that it made you question the fabric of reality itself? Perhaps you experienced a strange coincidence, a glitch in the matrix, leaving you wondering if our universe is truly what it seems. What if everything we know, everything we feel and experience, is nothing more than an elaborate simulation? It's a question that has captivated philosophers and scientists for centuries, a tantalizing puzzle that dances on the edge of our understanding. The very essence of reality, the foundation upon which we build our lives, is suddenly thrown into question. Are we merely characters in a cosmic video game, our actions predetermined by lines of code written by an unknown programmer? It's a mind-boggling concept, one that challenges our most fundamental assumptions about the world around us. But what if this seemingly outlandish idea holds a grain of truth? What if the rapid advancements in technology, the blurring lines between the digital and physical realms, are not merely coincidental, but rather signposts pointing towards a profound revelation? The possibility, however remote, that we might be living in a simulated universe is both exhilarating and terrifying, urging us to confront the limits of our perception and the very nature of existence itself. Join us as we embark on a captivating journey into the heart of the simulation hypothesis, exploring the scientific plausibility, the philosophical implications, and the mind-bending evidence that suggests our reality might be far stranger than we ever dared to imagine. Imagine a world indistinguishable from our own, a world teeming with life, history, and experiences that feel utterly real. Now, picture this world as a sophisticated computer program, a digital construct created by an intelligence far exceeding our own. This, in essence, is the crux of the simulation hypothesis. The idea that our perceived reality is not the fundamental layer of existence, but rather a simulation running on a powerful computer system. This mind-bending concept, once relegated to the realms of science fiction, has gained increasing traction in recent years, fueled by advancements in fields like computer science, physics, and philosophy. It's a notion that has captured the imagination of leading thinkers like Elon Musk, who famously stated that the odds of us living in a simulation are 1,000,000,000 to 1. The simulation hypothesis rests on the premise that if a civilization reaches a certain level of technological sophistication, it would be capable of creating incredibly realistic simulations, perhaps even entire universes. These simulations, populated by simulated beings with their own experiences and perceptions, would be indistinguishable from a real universe to those within it. But why would a civilization create such simulations in the first place? The motivations could be varied, from scientific curiosity to entertainment, or even as a way to preserve a digital copy of their civilization. Whatever the reason, the sheer number of potential simulations compared to the single instance of a real universe leads some experts to believe that the probability of us existing within a simulation is surprisingly high. As we delve deeper into this rabbit hole, we'll examine the arguments for and against the simulation hypothesis, exploring the scientific evidence, the philosophical implications, and the potential consequences of discovering that our reality is not what we thought it was. Buckle up, because the journey ahead promises to be a wild ride. Imagine a computer program so advanced that it could generate an entire universe, complete with galaxies, planets, and life forms like us. This, in essence, is the crux of the simulation hypothesis. It proposes that our reality, the one we perceive as real, is not the base reality, but a meticulously crafted simulation running on a supercomputer created by a civilization far more advanced than our own. Think of it like a highly advanced version of a video game. Just as characters in a game are unaware that they exist within a digital world, we might be oblivious to the fact that our thoughts, emotions, and experiences are all part of a sophisticated program. The difference, of course, is the sheer scale and complexity of the simulation we're talking about. A universe so vast and intricate that it encompasses everything we've ever known. This idea might sound like something straight out of science fiction, but it's a concept that has been seriously considered by philosophers and physicists alike. It's a testament to the rapid pace of technological advancement that what once seemed like an outlandish idea is now within the realm of possibility, at least theoretically. The implications of this are mind-boggling. If our reality is a simulation, then who are the architects of this digital realm? What are their motivations for creating us, and what does it mean for our understanding of free will, consciousness, and the meaning of life itself? These are just some of the questions we'll explore as we delve deeper into the simulation hypothesis. One of the most compelling arguments for the simulation hypothesis comes from Swedish philosopher Nick Bostrom. In his seminal 2003 paper, Are We Living in a Computer Simulation? Bostrom presents a thought experiment that has become known as Bostrom's trilemma. Bostrom argues that at least one of the following statements must be true. 1. Civilizations like ours are highly likely to go extinct before reaching a post-human stage where they can create such simulations. 2. Post-human civilizations have no interest in creating simulations of their past or other civilizations. Or 3. We are almost certainly living in a simulation. The first possibility, extinction before reaching a post-human stage, is certainly plausible given the numerous existential threats we face, from climate change to nuclear war. The second possibility, lack of interest in simulations, seems less likely. After all, we humans are already fascinated by simulations, from video games to virtual reality experiences. It's not hard to imagine that a more advanced civilization might be even more drawn to creating and exploring simulated worlds. This leaves us with the third and perhaps most mind-bending possibility, that we are indeed living in a simulation. Bostrom argues that if post-human civilizations exist and have the capacity to create simulations, and if they choose to do so even on a relatively small scale, then the number of simulated universes would vastly outnumber the single instance of base reality. Statistically speaking, this would make it far more likely that we are living in a simulated reality than in the original one. While this argument doesn't prove that we are living in a simulation, it does make the possibility seem less like science fiction and more like a legitimate scientific hypothesis. Another factor lending credence to the simulation hypothesis is the exponential growth of computing power. Moore's law, the observation that the number of transistors on a microchip doubles approximately every 2 years, has held true for several decades, leading to an unprecedented increase in computing power. If this trend continues, even at a slower pace, it's conceivable that we will one day have computers capable of simulating entire universes down to the quantum level. Quantum computing, a revolutionary technology still in its infancy, promises to further accelerate this progress, potentially allowing us to perform calculations that are currently impossible for even the most powerful supercomputers. Moreover, the amount of data we are generating and storing is also growing at an astonishing rate. Every click, every search, every interaction in the digital world generates data that can be used to train increasingly sophisticated algorithms. These algorithms, in turn, are powering the rise of artificial intelligence, which is becoming increasingly capable of mimicking and even surpassing human intelligence in certain domains. The convergence of these technological advancements, exponential computing power, quantum computing, and artificial intelligence, makes the possibility of creating highly realistic simulations more plausible than ever before. While we are still a long way from simulating an entire universe, the rapid pace of technological progress should give us pause and make us wonder if we are not already living in a digital realm created by beings far more technologically advanced than ourselves. The simulation hypothesis hinges on the crucial question of whether a civilization could ever achieve the technological prowess needed to create such a complex simulation. While it may seem like an insurmountable feat, the relentless march of technological progress, particularly in computing power, suggests that it might not be as far-fetched as it once seemed. At the heart of this technological revolution lies a concept known as Moore's Law. Coined by Gordon Moore, co-founder of Intel, Moore's law states that the number of transistors that can be placed on an integrated circuit doubles approximately every 2 years. This exponential growth in transistor density translates directly into increased computing power, allowing us to do more with less and at a faster pace. What once required room-sized computers can now be accomplished by devices that fit in our pockets. For decades, Moore's law has held remarkably true, driving innovation in countless fields, from artificial intelligence to biotechnology. While some experts believe that Moore's law is approaching its physical limits, others argue that new materials and computing paradigms, such as quantum computing, will continue to fuel exponential growth in computing power for the foreseeable future. The implications of this continued growth are profound. If computing power continues to increase at an exponential rate, it's conceivable that we will one day have computers capable of simulating not just simple environments, but entire universes with incredible detail. Imagine a computer program so sophisticated that it could generate galaxies, stars, planets, and even life itself, all governed by the laws of physics as we understand them. While traditional computers, even the most powerful supercomputers, face limitations in simulating the vast complexities of a universe, a new breed of computing known as quantum computing offers a tantalizing glimpse into the future of simulation. Quantum computers harness the bizarre laws of quantum mechanics to perform calculations in ways that are impossible for classical computers. Unlike classical bits, which can only exist in a state of 0 or 1, quantum bits, or qubits, can exist in a superposition, simultaneously representing both 0 and 1. This allows quantum computers to perform multiple calculations simultaneously, giving them an exponential speed advantage for certain types of problems. One area where quantum computers hold particular promise is in simulating quantum systems themselves. The behavior of atoms, molecules, and subatomic particles is governed by the often counterintuitive laws of quantum mechanics, making them extremely difficult to simulate using classical computers. Quantum computers, on the other hand, are naturally suited to tackling such simulations, potentially revolutionizing fields like materials science, drug discovery, and our understanding of the universe at its most fundamental level. If we could simulate the quantum world with sufficient accuracy, it begs the question, could we simulate an entire universe from the ground up, complete with all its complexities and emergent properties? While still in its infancy, quantum computing represents a paradigm shift in our technological capabilities, opening up possibilities that were once considered the realm of science fiction. Section 3. Data deluge, fueling the simulation. A simulation, no matter how sophisticated, is only as good as the data that fuels it. Fortunately, we live in an age of unprecedented data generation. Every click, every search, every interaction in the digital world generates a torrent of data that is constantly being collected, stored, and analyzed. This data deluge, far from being a burden, is a treasure trove of information that could be used to create increasingly realistic and immersive simulations. From social media posts to sensor readings, from financial transactions to medical records, we are generating data at an exponential rate. This data, when properly analyzed, can reveal patterns, trends, and insights that would have been impossible to discern before. It's this data that powers the algorithms that recommend products, filter spam, and even diagnose diseases. In the context of the simulation hypothesis, this vast and ever-growing pool of data could be used to create simulations that are not just visually realistic, but also behaviorally accurate. By analyzing the data generated by billions of people, a sufficiently advanced civilization could potentially create simulated beings that behave in ways that are indistinguishable from their real-world counterparts. Imagine a simulation populated by artificial intelligences that have learned to mimic human behavior, complete with our quirks, our emotions, and even our flaws. Such a simulation would be virtually indistinguishable from reality, at least from the perspective of those within it. Section 1. The exquisite balance of the cosmos. One of the most intriguing pieces of evidence that has led some to entertain the simulation hypothesis comes from a seemingly unrelated field, cosmology. The study of the universe's origins, evolution, and large-scale structure reveals a universe finely tuned for life, with physical constants and laws so precisely calibrated that even slight deviations would render the universe sterile. This fine-tuning is often cited as evidence for a creator deity, but it could also be interpreted as evidence for a simulated universe. Think of it this way. If you were to create a simulated universe, you would need to set the initial conditions and physical laws very carefully to ensure that stars, planets, and ultimately, life could emerge. For example, the strength of gravity, the electromagnetic force, and the nuclear forces are all finely balanced to allow for the formation of stars, galaxies, and the chemical elements necessary for life. Even slight variations in these forces would result in a universe where stars burn out too quickly, galaxies fail to form, or atoms themselves are unstable. This exquisite balance, while not definitive proof of a simulation, is certainly suggestive. It's as if the universe we inhabit were carefully designed with life in mind, much like a programmer would carefully craft the rules of a simulated world. While other explanations for the fine-tuning of the universe exist, the simulation hypothesis offers a compelling and thought-provoking perspective. Quantum mechanics, the branch of physics that governs the behavior of matter at the atomic and subatomic levels, is notorious for its strangeness. Particles can exist in multiple states simultaneously. Information seems to travel faster than the speed of light, and the act of observation can influence the outcome of an experiment. This inherent weirdness, while baffling to physicists and lay people alike, could be seen as further evidence for the simulation hypothesis. Just as a poorly coded video game might exhibit glitches or bugs, the strange and counterintuitive behavior of the quantum world could be interpreted as imperfections in the simulation we inhabit. For example, the phenomenon of quantum entanglement, where two particles become linked and can influence each other instantaneously regardless of distance, seems to violate the principle of locality, which states that an object can only be influenced by its immediate surroundings. This spooky action at a distance, as Einstein famously called it, could be a sign that our universe is not as fundamentally continuous as we perceive it to be. Similarly, the Heisenberg uncertainty principle, which states that we cannot simultaneously know both the position and momentum of a particle with perfect accuracy, could be seen as a limitation imposed by the finite computational resources of the simulation. Just as a computer program can only render a certain level of detail, our simulated universe might have inherent limitations in its ability to represent reality with perfect fidelity. If our reality is indeed a simulation, one might expect to find subtle hints or glitches that betray the true nature of our existence. While definitive proof remains elusive, there have been anecdotal accounts and unexplained phenomena that have led some to believe that we might be catching glimpses beyond the veil of the simulation. These glitches in the matrix, as they are often called, range from the seemingly mundane, such as experiencing déjà vu or feeling a sense of premonition, to the more bizarre, such as objects disappearing or reappearing without explanation, or encountering seemingly impossible coincidences. While most of these accounts can be explained away as tricks of the mind, faulty memory, or simply coincidence, some remain stubbornly unexplained. The persistent human fascination with the paranormal, with stories of ghosts, ESP, and other unexplained phenomena, could be seen as a subconscious yearning for something beyond the confines of our simulated reality. Of course, it's important to approach such claims with a healthy dose of skepticism. The human mind is notoriously prone to biases and misinterpretations, and the desire to believe in something extraordinary can often cloud our judgment. However, the possibility, however remote, that we might be catching glimpses of the underlying code of our simulated universe is a tantalizing one that should not be dismissed out of hand. Our understanding of reality is inherently limited by our senses and our ability to process information. We perceive only a narrow band of the electromagnetic spectrum. Our hearing is confined to a limited range of frequencies, and our sense of touch is restricted to the surface of our bodies. What we experience as reality is essentially a filtered and interpreted version of the world around us, shaped by our senses, our brains, and our prior experiences. This raises the intriguing possibility that our perception of reality could be manipulated or even completely fabricated within a simulated environment. Imagine, for example, that we are living in a simulation with a limited resolution or frame rate. Just as a video game might render distant objects in lower detail or struggle to keep up with fast-paced action, our simulated universe might have subtle limitations that we are normally unaware of. Furthermore, our consciousness, the very essence of our being, could itself be a product of the simulation. Our thoughts, emotions, and experiences could all be generated by algorithms designed to mimic the subjective experience of being human. If this is the case, then the very concept of a real world outside the simulation might be meaningless. While it's impossible to prove or disprove the existence of a reality beyond our perception, the simulation hypothesis challenges us to question the nature of our own existence and to consider the possibility that what we perceive as real might be just a small part of a much grander and more complex reality. The simulation hypothesis, while captivating, rests on the assumption that a civilization could achieve the computational power necessary to simulate an entire universe. However, even with exponential growth in computing power, the sheer scale of such an endeavor presents a formidable challenge. To simulate a universe like ours, down to the quantum level, would require a computer of unimaginable power, far beyond anything we can currently conceive. Every atom, every photon, every interaction would need to be accounted for in real time. The energy requirements alone would be astronomical, likely exceeding the total energy output of a star. Furthermore, the simulation wouldn't just need to compute the physical laws of the universe. It would also need to simulate the experiences and consciousness of every sentient being within it. This would require modeling not just the physical structure of brains, but also the emergent properties of consciousness, something we are far from understanding, let alone replicating. While it's impossible to rule out future breakthroughs in computing that could make such a simulation feasible, the computational challenges involved are so immense that they strain the limits of credulity. It's possible that we are underestimating the computational power of a sufficiently advanced civilization, but it's equally possible that the simulation hypothesis simply asks too much of even the most technologically sophisticated beings. One of the most persistent criticisms of the simulation hypothesis centers around the elusive nature of consciousness. Even if we could simulate the physical universe in perfect detail, would that be enough to create genuine subjective experience? Could lines of code ever truly capture the feeling of what it's like to be human? Consciousness, the subjective feeling of awareness, remains one of the biggest mysteries in science and philosophy. We don't yet understand how it arises from the physical matter of the brain, and some argue that it may be a fundamental property of the universe, not reducible to physical processes. If consciousness is indeed fundamental, then it's difficult to see how it could be simulated. A simulation, by definition, is a model or representation of something else, not the thing itself. Just as a simulated flame can't generate real heat, a simulated consciousness might not be capable of genuine subjective experience. Proponents of the simulation hypothesis often counter that a sufficiently advanced simulation could induce the illusion of consciousness in its inhabitants, even if they weren't truly conscious in the same way that we are. However, this raises the question of whether there is a meaningful distinction between genuine consciousness and a perfect simulation of it. If we can't tell the difference, does it even matter? Occam's razor, a principle attributed to the 14th century philosopher William of Occam, states that, given competing explanations for a phenomenon, the simplest explanation is usually the correct one. In other words, we should not multiply entities beyond necessity. Applied to the simulation hypothesis, Occam's razor suggests that the idea of a simulated universe might be an unnecessary complication. While the hypothesis can explain certain aspects of our reality, such as the fine-tuning of the universe or the strangeness of quantum mechanics, It also introduces a whole host of new assumptions and complexities. For example, the simulation hypothesis requires us to believe that a civilization capable of creating such a simulation exists, that they have a reason for doing so, and that they have managed to do so without leaving any detectable traces of their existence. These are all significant assumptions that, while not impossible, are not supported by any direct evidence. Furthermore, there are often simpler explanations for the phenomena that the simulation hypothesis attempts to explain. The fine-tuning of the universe, for example, could be explained by the anthropic principle, which states that the universe must be compatible with the existence of observers, or by the existence of a multiverse, where our universe is just one of many with different physical laws. One of the most significant criticisms of the simulation hypothesis is that it is inherently unfalsifiable. A falsifiable hypothesis is one that can be disproven through observation or experimentation. If a hypothesis is not falsifiable, then there is no way to test its validity, and it remains purely speculative. The problem with the simulation hypothesis is that any evidence we could gather, even evidence that seems to support the hypothesis, could itself be part of the simulation. If we were to discover a glitch in the matrix, it could simply be a pre-programmed event designed to test our awareness or to maintain the illusion of reality. Furthermore, even if we could somehow break out of the simulation, there would be no way to prove that we weren't simply entering another, even more sophisticated simulation. The very nature of the hypothesis creates a closed loop where any attempt to prove or disprove it is ultimately futile. This doesn't mean that the simulation hypothesis is wrong or meaningless. It can still be a valuable thought experiment that challenges our assumptions about reality and encourages us to think critically about the nature of our existence. However, it's important to recognize its limitations as a scientific hypothesis and to acknowledge that it may ultimately be an unanswerable question. The simulation hypothesis doesn't just touch upon the scientific. It unravels profound philosophical questions that have lingered for centuries. If we are indeed living in a simulation, what does that say about our understanding of reality? Is the world we perceive, a world rich with experiences and emotions, any less real if it's ultimately composed of bits and code? This line of questioning forces us to confront our definition of reality itself. Is reality solely defined by its tangibility, by our ability to interact with it physically? Or could a simulated reality, indistinguishable from a real one, hold just as much weight and significance, especially if the simulated beings within it experience emotions, form relationships, and live out their lives as we do? The very concept of free will is thrown into question. If our actions are predetermined by a program, are we truly the masters of our fate? Or are we merely playing out a script, our choices illusory? This raises a debate about determinism versus free will, a philosophical conundrum that has occupied thinkers for generations. Does knowing we might be in a simulation negate our choices? Or do we continue to act with agency within the parameters of our existence, simulated or otherwise? The implications for morality are equally profound. If our actions have no bearing on a real world, does that absolve us of responsibility? Or do moral obligations hold within the context of the simulation, regardless of its true nature? The simulation hypothesis doesn't provide easy answers. Instead, it illuminates the ethical gray areas we grapple with, urging us to examine the foundations of our moral compass. The simulation hypothesis doesn't just challenge our understanding of reality, it also prompts us to reconsider the meaning of our existence. If we are virtual beings within a grand simulation, what is the purpose of our lives? Does our existence have inherent meaning, or are we simply data points in a cosmic experiment? The traditional frameworks for finding meaning, religion, philosophy, personal achievement, take on a different hue when viewed through the lens of the simulation hypothesis. If a programmer created our simulated universe, do they dictate our purpose? Or do we have the freedom to create our own meaning, even within the confines of a pre-programmed existence? The search for meaning takes on a new dimension. Instead of looking outward to the cosmos, perhaps we should be looking inward, examining the richness of our simulated experiences, the complexity of our relationships, and the simple joys and sorrows that make up a life. The simulation, if it is one, is incredibly intricate, filled with beauty, suffering, and everything in between. Exploring it, learning from it, and connecting with others within it could hold its own intrinsic value. And what of the programmers? If such beings exist, are they benevolent overseers, indifferent observers, or something in between? Do they intervene in our affairs, observe us for their own purposes, or leave us to our own devices? The very act of simulating a universe implies a certain level of curiosity, perhaps even a desire to understand the complexities of life and consciousness. The simulation hypothesis, while unsettling, ultimately leaves us with more questions than answers. But in those questions lies an invitation to think critically about our place in the universe, to appreciate the wonder and fragility of existence, and to find meaning and purpose in a reality that might be far stranger than we ever imagined. As we stand at the precipice of the unknown, gazing into the swirling vortex of the simulation hypothesis, one thing becomes abundantly clear. The universe, whether simulated or not, is a place of profound mystery and awe-inspiring wonder. The very fact that we can contemplate our existence within such a grand cosmic scheme is a testament to the power of human curiosity and our insatiable thirst for knowledge. Throughout this exploration, we've delved into the scientific plausibility of a simulated reality, examining the exponential growth of computing power, the mind-bending implications of quantum mechanics, and the possibility that our universe is finely tuned for life by design or by chance. We've grappled with the philosophical quandaries raised by the simulation hypothesis, questioning the nature of reality, consciousness, free will, and the meaning of life itself. And yet, for all our inquiries and speculations, the ultimate answer remains tantalizingly out of reach. The simulation hypothesis, while a powerful tool for critical thinking and exploration, may ultimately be an unprovable proposition. But perhaps that is not the point. Perhaps the true value of this thought experiment lies not in finding definitive answers, but in the journey itself. For in questioning the nature of our reality, we are forced to confront our own assumptions, biases, and limitations. We are compelled to expand our thinking, to embrace uncertainty, and to appreciate the sheer improbability of our own existence. Whether we are simulated beings in a digital universe or conscious entities in a physical one, the fact remains that we are here, experiencing this moment, contemplating the vastness of it all. The simulation hypothesis, like many profound philosophical and scientific inquiries before it, will likely remain an open question, a source of endless debate and speculation. But that is not a cause for despair, but rather an invitation to continue exploring, questioning, and pushing the boundaries of our understanding. The quest for truth is an ongoing journey, not a destination. Every answer we uncover only leads to more questions, propelling us further down the rabbit hole of knowledge and discovery. The simulation hypothesis, while perhaps unprovable, has already sparked countless conversations, inspired new avenues of research, and challenged us to think differently about our place in the cosmos. As we continue to unravel the mysteries of the universe, from the subatomic realm to the farthest reaches of space, we may one day find definitive proof that we are living in a simulation, or we may not. But regardless of the outcome, the pursuit of knowledge itself is a noble and worthwhile endeavor, one that enriches our understanding of the universe and our place within it. So let us embrace the unknown with open minds and a spirit of curiosity. Let us continue to ask the big questions, to explore the boundaries of our reality, and to marvel at the wonders of the universe, simulated or not. For in the words of the great Carl Sagan, somewhere, something incredible is waiting to be known. And who knows, perhaps the most incredible discovery of all awaits us within the very fabric of our existence. That's all for today. Thanks for tuning in. For more videos like this, please don't forget to like and subscribe our channel.